All right, so here we have going back to the to this what we were talking about earlier, right? If you have more than two tables, I'm sorry, more than one table, in this case, a student in the department, right? The default behavior is that we're considering all possible combinations, right, of all the records of one of the tables with all the records of the other table, right? So in this case, we have three departments and we have 9 students, right? And so there are 27 combinations, right, of each department with of all departments with all the students. Yes. Obviously, some of those combinations make no sense, right? Because we don't have all students enrolled in all the departments. Instead, we have students enrolled in a single department. So more typically, there'll only be certain records that make sense, certain combinations that make sense, and some that don't. So yeah, so they're way. Also, notice that we have all 6 fields, right? 4 fields from the student and 2 fields from the department. Maybe we don't want all the fields, right? We want to be able to select the ones we want. So how do we do that? Well, one of them is first of all, if you have 2 tables, one of the things you need to consider is, well, what if you want to what if some fields in one of the tables is the same as another one, right? So for instance, if you have 2 tables, right, in this case it's a student and student, notice that we have renamed them, so we can say S1 and S2, right? So that's okay. It's the same table, but we have renamed them so that we can refer to them differently, right? And we certainly have fields here that are the same, obviously, right? Because name appears in the same table. It's coming from the same table. So to be able to refer to them differently, we need to explicitly rename them as name1 or as name2. Otherwise, we would have 2 columns in the result set, right, that have the same name. That makes no sense. So we can rename them. Or we can also say that some of the relationships here make no sense. We only want the subsets where the relationships make sense, right? And that's where we can use the keyword join. So join allows me to specify, right, as you're iterating U1 with all the combinations of D2. I don't want all of them. I only want the ones where the relationship makes sense. That U1 has a relationship with D1. But I don't want the ones with U1 has a relationship with D2. That's not specified, right? U1 here is a relationship with D2, not with D1, right? So that's what join does. Join says, take the 2 tables, right, student and department, and I only want the ones that are joined where this predicate is true, right? Where the student major is equal to department primary key. If that's true, I want that record. Otherwise, I don't want it. Okay. Also notice that we don't want all the fields, right? We don't want all 6 fields. I only want the student name and the department name, right? I'm going from the multiple tables into a single table result set, right? So this here, right? Like the keyword says, we call it a join, and we call it join because these were 2 tables that we know the data is actually related to one another, right? And I like to reconstruct the original relationship between the 2. I want to join them, right? Join them, even though the data has been split, I want to join it back together because they are related, right? The only reason we split them in the first place is because we want to remove redundancy and avoid inconsistency. But the data is indeed together, right? Is logically together. We just split it for removing inconsistency. Now, depending on what you're doing here, there's several types of joins, right? There's the most common join that we'll be using is called the inner join, right? Or oftentimes we just call it join. Usually when somebody says joining, usually they mean an inner join. An inner join is basically, right, where the primary key of one of them is equal to the foreign key of another, right? I only want the ones that match. Okay, if U1 has a reference to D1, that's the one I want. Right? I don't want any other ones. But there might be other ones. We'll see in a minute. Left, right, and full outer joins, and we'll see when we use one or the other. Whenever we say left or right or anything, what we mean here is that if you take the join keyword, right, and we look at the table on our left, right, there will be also a table on the right, right? That's what we mean by left and right, right? It says, well, what do you want of the left and right? We'll see in a minute, but that's what we mean. We mean by that looking at from the point of view of the join keyword, are we referring to the left or the right? And we'll see that what that means in a minute. Also, usually the on right keyword identifies what the predicate is of which records do I want where these two are the same, where they match. And usually that match will be some foreign key, right, is equal to the primary key of some other table, right? But it doesn't have to be. You can join on other things, right? You can join on other things. But the most common one is joining on primary key and foreign key. So let's take a look at a couple of joins here. We have a couple of folks here and orders. We have Boone, Dole, and Garcia, and we have their addresses, their cities, and whatnot. And notice that we have some products, with the order numbers and whatnot. But notice that they're related to one another, right? The orders and the persons are related to one another. Yes, and they're related through this foreign key, right? This foreign key tells me who ordered this, right? This was ordered. These two were ordered by Garcia. These two were ordered by Boone, and this nobody ordered this. Somehow it's orphaned, right? It's nobody ordered that. It's pointing to something that doesn't exist. Okay, so let's take a look at that. So if we join, we can say, all right, well, take a look at both the person P on the left and the orders O on the right, and I only want the records that meet this criteria, where the foreign key is equal to the primary key. That's a straight inner join, right? So we just call that typically a join, right? But usually when we say join, we mean an inner join. Make sense? And this is the most common type of join that we'll be using throughout. Now, sometimes there might be things that don't match. Okay, for instance, if you notice that there was that ordered record that wasn't pointing to anybody. Okay, sometimes we might say, well, even if they don't match, I still want those records. Okay, but you tell me then which direction do you want, right? So for instance, over here we have if we have a left join, that means that I want all the records in the table one, even if they don't match. Okay, if there's nobody matching on the table two, why would you want that? Sometimes you do, right? We'll see a couple examples on why. So for instance, in this case, if we do a left join between these two, right? Notice that and again, it depends who's on the left and who's on the right, right? So here we have PID and we have the order ID, and if we do a left join, notice that Dole Bob, right? Now notice that there's an order that didn't match, right? Dole doesn't seem to have ordered anything, right? And an inner join, Dole would not be here because since Dole didn't order anything, there is no foreign key on one that matches on the primary key of Dole. So Dole would have not made it into this query. Yes, right. But because I'm saying left, I'm saying person P is on my left. I want those records even if they didn't match. Okay. So there it is. So this is what I would get. And we would see that empty space on the order, that there's no order that matches that Dole. And so why would we ever want to do that? Go fetch records, even those that don't match. It's like, didn't we agree here that makes no sense to fetch records that don't match, right? So let's take a look at a couple of edge cases where we said, ooh, actually no, we do want those records, even the ones that don't match. Here, I made a case that you would never want those records that don't match, right? Well, let's take a look at this. Let's say we say the query is the following: you have staff and spouse, and you want to invite them, right? You want to invite the staff, and the staff has their own social security number, their first name, last name, and they might be married, right, or not. If they are married, there is a spouse record, right? And the spouse record has also first name and last name, their own social security number, but also they have a foreign key to who they are married to. Make sense, right? So in a straight inner join, and you want to invite the folks over, you might say, okay, well, invite the staff and their spouse, in an inner join, you would say, well, whenever there's a foreign key and a primary key that match, notice that you would only get invites to those folks that are married. If they're not married, they're not invited. Okay, which makes no sense, right? So in that case, right, the typically the requirement might read as, find me the names of each staff and member and his or her spouse, if any, right? Okay, that if any is a a red flag saying, oh, I might be a left join here. Okay, you might want the records, even the ones that don't match. So once we do that, right, we do so if you do straight inner join, right, you would only get send invitations to those people that are married, and you would be discriminating against anyone who's not married, who doesn't have a spouse, right, and you get in a big lawsuit. So instead of doing an inner join, right, you would do a left join, right. I want those staff, right, and if they're not married, that's fine. I want to invite them as well. Make sense? So yeah, so certainly there are cases where you might want to fetch all the records even if they have no match. Yes. No, doesn't matter. Yeah, no. So it might be a little more, it might be a little faster if maybe the spouse ESSN is on the left side, so that if there's no value, if it's a null, right, you're not even going to compare it, right? So yes, so you might decide to do in the order. Same thing if you have several nested joins, like you have a join with a join with a join with a join, right? You would order them in such a way that the earlier joins would provide smaller queries, right? So it would quickly just throw away thousands of records that you would not even consider, right? So that later joins, right, are smaller and smaller and smaller. Yes, well, they are always going to be smaller, right? But you start with the one that would cut out as much as possible first, right? So yes, there's an order. We'll talk about optimization a little later. So right join is just the right join is just the opposite, right? Where you want the tables on the right hand side or left hand side, right? And if you just have between two tables, it doesn't really matter if you go right or left. It only starts mattering if you have multiple joins, right? And you want to carry over and decide which one you're talking about, the left or the right, right? In this case, you just have two tables. It doesn't really matter, right? You can just invert them and you get the same results. So here we have a right join. We have the right join where in some cases it says I want all the orders, right? Even if nobody actually ordered it, right? There's no person that matches that order, right? I want all the orders, and I know there'll be a mismatch on the left hand side. Full joins, you want every single match on either table, even if they don't match. So for instance, if you have these two, you would be left over with all the last names, right? All the persons, plus the record that doesn't match on the right, and then plus all the right records, right, with the records that don't match on the left, right? This was called a full outer join, and typically this is a fairly expensive query that you should try to avoid. Now, if you want several joins, right, you can now use parentheses, right, so that you can treat them in groups of two, right? So for instance, this is a first join of students in enrollment, right? And the result of this join is going to be the left-hand side, right, of joining it with the section, right? So you can treat them in tuples, right? So first you join these two, and that result is then joined with sections. See that? And again, this join could be right or left join, right? But more typically, it's just an inner join. So you can group using parentheses and decide the order in which things are joined. Okay. So this one, for instance, first looks at the students and those enrollments. So first finds first finds the those students that are enrolled, right? And then the result of those enrollments, I'm going to extract, which sections are there in, right? From those enrollments that come through there. Now, if you start using these parentheses, and you have lots of joins, well, first it'll become very expensive, right? Because we saw that every new join adds a quadratic, increases the complexity. Yes. Oh, when you have two, it doesn't really matter. You can just swap them, right? But when you start putting the parentheses, right, now you want to, it might be convenient, right, to put the second section join here afterwards, right? So now it says, well, left or right, right? Now it becomes relevant in which order you want. Changing the order could be very, very cumbersome. Yeah. Um, Right. So if you're using multiple joins, right, this with all these parentheses could start becoming very unwieldy and very hard to read. So there's an alternative syntax, right, that allows you to replicate the same type of join, right, but using the where clause instead. Okay. So for instance, instead of using the inner join at the top, where you have employee inner join with department on this predicate, right? You could write the same exact thing, but using without the join, right? You can say use the in the where clause. You can put the predicate in the where clause, right, instead of the join, right? Now the syntax are usually referred to as, the first one is called an explicit join syntax, right? Where you have the join keyword and you have the predicate on the join, or what is called the implicit join notation, where you don't have the join keyword, right? And the predicate just lives in the where clause. Make sense? Right? Now the difference here is that in the where clause, typically you would put here predicates, right? That are not necessarily primary key, foreign key relationships, right? You could put things here that have nothing to do with the primary and foreign key. Maybe, salaries that are between so and so range. That has nothing to do with primary and foreign key. Yes, or folks that were, graduated after a particular year or whatever, right? Those have nothing to do with primary and foreign key. So in the where clause, you can mix and match different predicates, right? Some predicates might be relationships, like this foreign key and primary key, and some of the predicates might be not relational. Yes. So let's take a look at the talk about the where clause.